All right, welcome back. Today, we're diving into a secret language that's hiding in plain sight. It underpins, well, pretty much our entire modern world. We're talking finance, science, engineering, you name it. And once you see it, you'll realize it's a code you already use every single day. So what is this powerful, universal language? What's the code that scientists use to calculate the distance to Mars? And what do bankers use to track trillions of dollars right down to the penny? Believe it or not, it's the humble decimal. And I know what you might be thinking. Ugh, math class. But hang on, let's reframe that. Think of decimals as a secret code for expressing precision. In the next few minutes, we're going to crack that code together, and you'll see just how powerful it really is. So just like any language, this one has grammar, a set of rules that gives it all its structure and meaning. And for the language of decimals, the single most important rule, the entire foundation, is something called place value. So let's dive into the grammar.
Place value is a simple idea, but honestly, it's super powerful. A digit's value depends entirely on where it sits in line. The most important landmark here, the decimal point itself. You gotta think of it as the anchor that holds everything in its proper place.
Okay, so this table right here, this is basically our decoder ring. Let's take a look at the number 4.81. That 8 isn't just an 8. Because it's sitting in that first spot to the right of our decimal anchor, it's in the tenths place. That means its real value is 8/10, or 0.8. Its position is what gives it its power. Simple, right?
Oh, and this is a perfect example of a crucial part of the code. In the number 5.06, that 0 isn't just empty space, it's a critical placeholder. Seriously? It's holding the tenths place open, making sure the 6 lands exactly where it belongs, in the hundredths place. In this language of precision, 0 is a hero.
Okay, so we've got the grammar down, right? We understand place value. The next step to becoming totally fluent is, you guessed it, translation. We're going to see how to translate between the language of fractions and our new friend, the language of decimals. Now, the most important thing to get is that fractions and decimals are not enemies, not at all. They're just two different ways of writing the exact same value. 8/100ths can be written as the fraction 8/100 or as the decimal 0.08. They mean the same thing. It's like saying hello versus hola, just a different dialect for the same idea.
And the cool thing is, this translation key works both ways. Look at that second question here. What's the same as 0.08? Well, using what we just learned, we know that 8 is in the second spot past the decimal, which is the hundredths place. So boom, we can translate 0.08 directly into the fraction 8/100. It's a direct one-to-one translation.
All right, we've learned the grammar. We know how to translate. Now comes the really fun part, putting our new language to work. This is where the code stops being theory and becomes a tool for making smart, fast decisions.
Once you're fluent, you can make comparisons in a split second. I mean, look at 0.6 versus 0.06. You immediately know that 0.6 is bigger because the 6 is in the tenths place, which is 10 times larger than the hundredths place. Same for 5.12 and 5.2. That's like asking if $5.12 is less than $5.20. Of course it is. This is that precision we were talking about in action.
Of course, this code isn't just for comparing, it's for calculating. We can combine values with total accuracy. So how would we tackle a problem like adding 1.2 and 0.3? Let's check out the rulebook.
It's actually so simple. There are just 3 steps. First, and this is the absolute most important part, you align the anchors, the decimal points. Stack them up vertically so the points are in a perfectly straight line. Second, you just add up the numbers in each column, starting from the right just like you normally would. Finally, you just drop that decimal anchor straight down into your answer. And that's it. 1.2 plus 0.3 is 1.5. Clean, simple, and precise.
And there you have it. I mean, think about it. We started with a secret language, we learned its grammar, place value, we figured out how to translate it, and we put it to work. In just a few minutes, you've basically become fluent.
So, here are the key principles for your new decoder ring. Just remember, the decimal point is your anchor, separating the whole from the parts. Each place you move to the right gets 10 times smaller. Those zeros you see? They are critical placeholders, not just empty space. And never forget, decimals and fractions, they're just two sides of the same coin.
The really big takeaway here is this. What we've done today goes way beyond a math lesson. You have learned the fundamental language of precision, the very system our world uses to build, to measure, and to innovate with incredible accuracy.
So that leaves us with one final thought. You now understand a language that describes the world with amazing detail. The only question left is, now that you can read the code, what will you build with it? Thanks for joining me.